Hello, everyone. I'm Yiying Zhang. I'm an assistant professor at UCSD. Today, I'm excited to interview Ali Ghodsi, the CEO of Databricks. So maybe you can introduce yourself quickly before
Yeah,
we move on.
yeah, I'm a CEO and co-founder here at Databricks. There's actually six co-founders, and we started this company in 2013. And before that, I was visiting Berkeley for 4 years. Before that, I was a faculty in Sweden, where I also did my PhD in distributed systems and distributed algorithms.
Sounds good. So this interview will cover three perspectives. One is from academia, and then from business side, and then finally from technology side. So let's start from academia and some personal question. So why did you decide to move from academia to industry and do a startup? And have you thought about going back to academia?
Yeah, good questions. One thing I learned early on in academia was that if you really want to have big impact with your research, you pretty much have to do it yourself. I looked at examples in the past, like 10, 20 years. It turns out that usually when some great idea from academia was actually sort of adopted by industry, it turns out that there actually was a person from academia who took the idea and went out there. For instance, as an example, Paxos is a consensus algorithm, one of many consensus algorithms. There's hundreds of them, maybe thousands. But why did Paxos become so prevalent? Well, actually, it turns out one of the researchers at Cornell who did his PhD on consensus objects was one of the early Google guys. And there, he made sure that he actually implemented it and adopted it there. So his name is Tushar. And that way, Paxos got adopted. So in general, I think if you want to really have impact with your research, you should probably go out there and do it yourself, or have someone else that actually adopts it. Just publishing great papers in conferences and then sitting back and hoping that someone from industry will read the paper and adopt it, it's not going to happen. So that's the reason. Going back, I mean, when I started, I thought I'm going to do this for just a couple of years and then go back. But then Databricks grew bigger and faster than we all thought. So it seems it's far away now.
Yeah, that's good. So you mentioned that for a research project to be successful, someone has to go there and really build it. So Spark is a very good example of successful transfer from research to production. So do you have any experience to share?
Well, Spark is actually a great example. I mean, it had adoption. It was pretty popular. Started in 2009. But 2013, when we started Databricks, it wasn't a huge worldwide phenomenon. People didn't know about it everywhere. And most people you would talk to outside of academia wouldn't know what Spark is. And those who knew what it is had a lot of misconceptions. They would say, oh, it's just for in-memory computation. But what if you have more data than fits in memory? And we would tell them, of course, we can compute the data on disk. It's really trivial. It's not hard. But they would say, no, but I heard that you can't do it and you run out of memory and so on. So it wasn't actually until Databricks was created as a company and we invested a lot of money into R&D and marketing. And actually, we participated in a contest, the sorting contest, where we set the record for 1 petabyte sort. And we did that with a cluster with less than 1 petabyte of memory. We kind of proved it to people. And then we paid the PR firm that actually marketed that, and then people sort of started realizing, okay, that's true. If you can sort a petabyte without a petabyte of memory, maybe you can do on this computations. So, so really, Spark, really, the hockey stick took off in 2015, 2 years after we started Databricks. Of course, it was already a successful research project and also had a lot of adoption, but not at the scale of sort of industrial enterprise adoption. Very few enterprises on the planet would know what Spark is, probably almost none in, say, 2012.
So you think the key here is just to start a company and make it a product?
Or some company adopts it for you. There's some company that actually adopts the technology. Keep in mind, the same co-founders, we also created Mesos. And with Mesos, we had to put a student almost full-time at Twitter. And was Ben. And he spent all his time there just to get it adopted. And it was a huge battle. And eventually, he got Twitter to adopt Mesos. But then also, they have to have a company behind it, Mesosphere. And it took many, many years before that got the adoption it needed. So I just think it's almost a little bit naive when we publish papers, and then we wait for the, okay, if it gets best paper award, it's going to get implemented. It's not. Industry is not paying attention. So we have to do it ourselves, or get someone that we know do it for us. But just assuming that it's someone else's job, unfortunately, probably the good ideas will not be adopted.
So what about open source? So Spark has been an open source project from the
Yeah.
start. So how do you find the business model, or do you think someone else would just pick up the open source project?
Yeah, that's a good question. I think there are two business models for open
Mm-hmm.
source. One is really well understood. I call it the Red Hat monetization open source model. In the Red Hat open source monetization model, you have some open source software, and anyone can download it and run it on their own. But you are the enterprise support, the training and education, and the services if they need custom implementation, and you do that. The problem with that business model is that it's actually the value add that you're selling as a company, the support, the services, the education, actually gets commoditized quickly, especially in this day and age where knowledge spreads quickly.
Mm-hmm.
It's very easy for some consulting firm to say, hey, we also have knowledge about Hadoop or Red Hat or whatever the technology Spark, and we can do services for that too, and we can do it cheaper because we do it offshore.
Yeah.
So that business model is not so viable. There's another business model for open source, which is extremely successful, and that's the Databricks one. And actually, we didn't invent it. I think you have to probably attribute it to AWS. So it's a business model where you actually run the open source software as a service. So it's SaaS, right? The SaaS monetization model of open source. And in that model, it's much different. It's not the support and services and education that you do, but it's actually operating the service. So in particular, it's making sure that the service is up and running at all times, that it's upgraded without anyone noticing,
Right.
and making sure that it's secure at any given time.
Mm.
And that's actually hard. It's very hard to upgrade the software without affecting any of the existing sort of workloads. It's very hard to make sure that you have all the reliability and SLAs. It's not easy, especially doing it at massive, massive scale for an enterprise to rely on your software. And third, making sure that it's secure. There's a data breach, it's on your company. And companies then rent your service from you and pay you by the hour. And that business model is much more defensible. Look at AWS. It's grown exponentially fast. And you can see the same thing with Databricks, also exponential revenue growth. And the margins are amazing. And what you're doing is not going to get commoditized because it's actually really hard. Unlike education services and so on that get commoditized, it's actually really hard to operate software in the cloud. It's very, very hard. Very few companies know how to run cloud software that's reliable and secure and available. It's Google, Amazon, maybe a few startups, but it's not thousands of companies that do this for a living. So that's our business model. And if you're doing your own open source company as a student, I would definitely do a SaaS open source business model.
Sounds good. So let's move on to more academia questions.
Okay.
So other than Spark, has the Databricks adopted some other research ideas, or has any research idea influenced Databricks products?
Yeah, our history is that we started with the resource management. So we were working on Mesos, and we actually built cluster management internally here, which was highly influenced by the work we did on Mesos. We adopted Kubernetes, which actually the Kubernetes teams at Google that originally developed it, they were actually working with us previously at the project called Omega at Google. They were working with the Mesos team. So it's actually the same group, and the ideas have been actually sort of disseminated between these different researchers and the companies that have been working on resource management. So resource management is a big deal for us. It's a big part of what we do. Every day we launch 1 million virtual machines on the cloud right now, roughly. I'm sure the number will be much higher when you show this. And doing that at scale is hard, especially reliably. So that gets to resource management. So that's one idea that definitely came from academia and our roots there. I would say we adopt a lot of different open source software internally. I mentioned Faxos earlier, but we run a lot of key value stores that at their core are making sure that we have consistent services that are up and running. So things like Console that we use, which is not directly from academia, but a lot of the things that they implement under the hood came from probably academia. The way we build our systems, we based on a lot of ideas on papers that we had read early on. So recovery-oriented computing was a paper actually from Stanford from back in the day. We tried to build a lot of our systems based on that principle, which is make sure that you can kill any service at any given time. Just assume that failures is a common norm. Then you will be very robust rather than having a special case for those. So that was a typical idea that we used as well. Other ideas when we actually built up Databricks in the early days were how to actually shard and scale the services. So that was very common. How to isolate resources, resource isolation, scheduling. So many of these ideas came from actually academia. So I mean, obviously we have like a paper reading group that reads papers,
wow.
and we published also quite a few papers at
Yeah.
Databricks, and actually those papers have more citations than some of the papers we published when we were in academia. So definitely we stay connected.
That's good. Okay, so the next question is more on the business side. What do you think are the important factors that lead to successful startup? And do you have any suggestion for students who want to do their own startup or join the early stage one?
So that's a big question. So we might have to refine a little bit and clarify some parts, or you should tell me which parts you want to double click on. But obviously, startups I think start with great product that has great product market fit. So you have to have that. Great product market fit means you're solving an actual problem for a big market. So big portion of the market, not just a niche or a small portion, which actually is the hard part, because when you're doing research, you're often doing niche research on a very difficult problem that no one has solved before. But how many people really need that problem solved? It might be a small number of people, and it might pay you a lot, those small number of people. But generally speaking, the successful startups are the ones that are attacking problems that are relevant for a big audience. So big TAM, total addressable market. And you have to have a fit. So it has to really solve that problem. You have to solve it much, much better than status quo. So I usually say 10x, but that's just a figure we throw out. But you have to be much, much better than what's out there. It's not okay to be 30%, 40%, because the best technology doesn't always win. But if your technology is orders of magnitude better in some dimensions that matter, then actually you have a great place to start. So let me give you an example. Databricks used Spark. Spark, it was kind of obvious that it was going to win if we just put the resources behind it, because it was better in 3 dimensions. And it was orders of magnitude better in 3 dimensions. Dimension 1 was performance. So it was beating MapReduce by almost 100x in speed. So already 2 orders of magnitude better in that. It was also much, much simpler. And actually, you could quantify it. Usually, the code you would have to write was usually a tenth of the code you would write in Java for, say, MapReduce or something else. So again, a 10x improvement. And then the third one, harder to quantify, but it supported machine learning, real-time streaming, ETL, SQL. So you had sort of in many different dimensions. So you could see that it was significantly better. That if you just had the right company behind it, you could actually monetize it. Of course, if Databricks didn't exist, you could have probably worked on Hadoop and improved it, and eventually over the years it will catch up. But you have to be much, much, much better from the get-go. I'll give you a cheat technique if you want to start a company to get product market fit, which I think people don't know about, which is it's very, very hard to figure out what product to build. Right? So there's lots of books on this, but actually none of them really. There's no recipe of do these 3 things and you will have product market fit. It's actually an art. There's no science to it, right? How do you build the next Facebook? How do you build an iPhone? Nobody really knows. You have to be a genius like Steve Jobs. But there is a shortcut. The shortcut is build an open source project, take your time, make sure that it gets adoption. And you can take your time. Don't do it in a startup. Once an open source project has massive adoption, it already has product market fit. Now figure out how to monetize it. That way you can kind of leapfrog and avoid the most difficult part of a startup, which is what is product market fit. In fact, you can cheat even more. Take an existing open source project that doesn't have enterprise backing and build a company around it. That's kind of what Cloudera did. They took Hadoop, which already had great product market fit at Yahoo, and they created a company around it. So that's a shortcut that you can take to avoid very difficult product market fit sort of experimentation when you're paying salaries and you're borrowing money from VCs and time is ticking.
That's like a very good shortcut for academia.
Yes,
to do.
In particular. If it works with the university and the licensing terms and so on, yes.
Oh yeah, so that's another story. So we may not have time to get into that, but if you do, I'll come back to that.
Sure.
So looking back, what do you think is the biggest challenge that Databricks has overcome, and any big challenge you personally have overcome?
Yeah, I mean, we went through a lot of challenges. Challenge number 1 was, how do we get Spark to get adoption? Again, people think, Spark was already a world. Everybody was using it. No, it's not true. Very few, I would say almost no enterprise on the planet knew about Spark. Maybe 1 or 2 or 3, maybe Yahoo knew about it. But if you look at the global 10,000 companies, not even 1% of them would know what Spark is. So our first challenge was, how do we get adoption? And we fought very hard from 2013 to 2015 to make sure that we would get adoption. And we did a lot of things. We went to meetups, we hosted meetups, we wrote a lot of documentation, wrote books about it, and we listened to customers, and we worked with the customers to try to get them to adopt it. So it was a big battle for us, and it happened almost overnight. The success came almost overnight in 2015. So that's 6 years into the project. Suddenly, overnight almost, everybody suddenly woke up and said, hey, Spark is the greatest thing since apple pie. And suddenly Gartner put it on the hype cycle, and all the Hadoop vendors said, oh, we love Spark, and they added Spark to their portfolio. It almost happened overnight in 2015, and it somehow correlated with our winning the contest of sorting. So we don't know if there's a causation there or not, but momentum gathered so much that eventually we got that. So that was the biggest breakthrough for us. That was step number one. But we had actually very little revenue at that time. In fact, we only had about $1 million revenue from the product, SaaS product, that year in 2015. So the next step was, okay, now we have a successful open source project. How do you monetize it? So the really difficult challenge then is, how do you build a go-to-market machine? So sales, marketing, and customer success to actually start working on that repeatable motion of selling to customers and pricing it and monetizing it. So that was the second, I would say, challenge that we faced. And we had to get the right leaders. And this is oftentimes very difficult for people from academia to do this. How do you hire a really, really great, phenomenal sales leader? It's not easy for someone who's been in academia to do that, because we don't know what a great salesperson looks like. In fact, what we think is a great salesperson, that might not be a great salesperson. And a great salesperson to us might seem, that's such a different person from who we are. So we might actually reject that person. So for that reason, I see a lot of founders struggle with that step. But we found a great person, Ron Gabrisco. And so that's the second challenge. How do you get that go-to-market machine scaling? I think the third challenge that everybody struggles with is, how do you make sure that you can fund all of this along the way? And it's actually not that hard. At least it hasn't been hard in the last 10 years to fund a Series A or a seed. But how do you continuously fund it? That's another challenge that you have to figure out to sort of attack. So that's another challenge in itself. How do you convince VCs and other investors that they should invest in your company? So I would say those are three big challenges that we've gone through. On a personal front, in academia, we're very sort of detail-oriented usually. I mean, we're known to be able to sort of go all the way very, very deep. When you're running a company now with 1,000 people, you have to delegate. So how can you delegate but at the same time verify? How can you trust but verify? That's just a different challenge. And I had to figure out how to do that, because in academia, you don't have to do that. If you're really, really smart, you can just read all your students' papers in detail. You can go one step. If you go N+1 levels deeper compared to anyone else, you can do really, really well. But here you have 1,000 people. So you can't go N+1. In fact, you're N minus, probably not even, some big delta, right? So how do you do that?
It's interesting that none of the big challenges you mentioned are related to technical side. No, they're not. It's actually the technical challenges that people are facing out there could be solved. They're not as hard. It's how do you get thousands of people to scale the machine? That's the hard part, and making sure that you can do that. You can fund that, and that they're all working on relevant things, and that you're going in the same direction and it's working. That's the hard part. So yeah, it's not technical. So a related question is, like, how has Databricks changed over the past 5 years, and how do you think it will change in the next 5 years?
Yeah, I mean, first couple of years, when you're like about 100 people or 200 people, below 100 to 200 employees, it's just different. Because if you have some really smart academics who are really sort of high throughput, you can probably keep track of everything. And you can know what everybody's doing, and you can like go down and you can make sure that almost all the decisions are consistent and being done correctly according to your belief system. Once you reach 100 or 200 people, and some people call it Dunbar's number, which is 150, you can no longer keep track of what everybody's doing. So there's actually a big shift that happens at that point. So and oftentimes you go from sort of a founders are running the company to like now you actually need traditional company hierarchy, and probably it's not the founders that are running it anymore. So that's one big phase shift that you go through. That's a real phase shift. The second phase shift that comes, which is very related to that, is once you start to build out different regions like Europe and Asia and so on. Cultures there are different. They're further away, and so how do you make sure that they actually succeed? When you build out your business in Europe or in Asia, it's actually starting all over again. So you have someone who actually starts, let's say, the Asia business,
Right.
but that person in Asia is almost starting Databricks from scratch, from zero. So it's almost back to 2013. He or she has to hire the first person, second, third, fourth, figure out how to tell the story of the company to the Asia, or actually the different countries, because Asia is not one country, right? It's like the culture in Japan is very different from China, from New Zealand. So so you have to start all over again. So doing that successfully in Europe, and then doing that successfully in Asia, and then elsewhere, that's another big phase shift that you're going through, and that's a costly experiment you're doing. So oftentimes many startups struggle with that phase, and if you get that wrong, it costs you much more than when you started the company. Because when you started a company, you're doing it small scale.
All right.
When you're scaling to Asia or Europe, you're doing it at pretty fast scale. So we're talking a lot of people, right? HR person, legal person for the different countries,
right.
Customer success people, finance person that can help out with the finances of that region, and then not to mention the sales machine that you need. So that's just on the go-to-market side. Then the product might need internationalization, the documentation might have to change. So there's a whole set of challenges that you go through with that. So that kind of takes us to where Databricks is today. Going forward, I don't actually exactly know what are the challenges that are going to come our way, but it becomes more and more focused on the metrics and the revenue. So for us, one of the big challenges will be going public. And once you go public, public markets are very focused on short-term gains and short-term financial metrics. So how do you continue innovating and being a company that can be successful for the next decade when you have Wall Street evaluating you on a quarterly basis? That'll be an interesting challenge for us to tackle.
Cool. So now let's move on to some of the technical questions.
Sure.
So again, looking to the future, what do you think are the top 3 technical problems Databricks will focus on in the next, let's say, few years?
Yeah, I think actually we're just at the very beginning of the cloud revolution. I know it might sound silly because, I guess 2009, 10 years ago, Berkeley wrote a paper called Above the Clouds, where it said the cloud is the future. But I actually still think the vast majority of data in enterprises are on-prem. So that moving into the cloud is going to be very interesting. So that's, I think, where I would spend a lot of my energy focusing on that problem. In particular, it's really hard running cloud services. As I mentioned, I don't think that many companies actually know how to operate cloud services at scale. Maybe there's 10 of them or maybe 20, but there aren't hundreds or thousands that are really good at doing DevOps. It's just very hard, and I can talk about all the challenges around that. But that, I think, is a very difficult problem, and I think also it's not well understood, and I don't think academia has written about it or really gone into depth on this. It is being done by companies like Databricks and others, but that, I think, is a real interesting area. That's one. Machine learning AI is another one, which I think we're just scratching the surface on that as well. And I think actually we've kind of focused on problems that are not that important for industry. So I think over the next decade, there's going to be a focus on that. So those would be, let's start with those 2.
Okay. Interesting. So you mentioned the Berkeley view towards cloud computing paper. So Berkeley has 2 more Berkeley view papers. One is like Berkeley view towards serverless computing and Berkeley view towards system challenges for AI. So towards these sort of like tech trends, what's your view towards like cloud side of trends like serverless computing and other things like hardware acceleration? How do you think Databricks products would adapt to these trends?
Yeah, I mean, serverless and cloud are almost the same thing. I mean, it's 2 sides of the same coin, right? Once you're buying the service in the cloud, why would you want to manage the individual machines or VMs or something, right? So of course you want to do away with, and the abstraction will move higher and higher and higher towards platform as a service. So I think they're almost the same thing. So that is definitely a trend that's going to continue. And so far, most of the serverless abstractions have been for stateless computations. They're not great for stateful, and I think the Berkeley View paper that we wrote mentioned that. So the question is, how do you run, for instance, something like Spark in a completely serverless fashion in the cloud?
Right.
So that'll be an interesting thing to tackle. I think most software written today is actually written for on-prem, so it's not based on this elastic serverless compute model. So a lot of the software will have to be sort of revamped into that model. So that's definitely coming. But just cloud itself is just how do you operate these services is itself really, really hard. And we don't really teach it in universities, right? And maybe you do.
I do.
Okay, that's good. So then you're ahead. But it's a lot of this is just, the people have to go through it and learn by falling.
Yeah.
How do you make sure that how can you upgrade services without it being down at all? How can you do it at scale without any regressions? That's the really hard part, because any regression threatens the whole business model.
Yeah.
Whenever a customer tells you, hey, please don't do that hidden upgrade next week because we have big business going on, that means actually that you're kind of failing with the whole cloud business model.
Yeah.
It should be completely transparent, right? It's like Google search. When you search on Google,
right,
which version of Google are you using?
Yeah.
No one knows.
Yeah.
It should be like that, but it's hard to do that for complicated software, like computations that you're running on behalf of customers, like we do. So those kind of things, I don't think it's super well understood and super well sort of trained into the masses of engineers that come out of the schools.
Yeah.
So that's going to be interesting. Then there's AI and machine learning, where I think the focus has been a lot on sexy results rather than results that actually matter.
Okay.
So that I think there's going to be a lot of focus on that.
So what are the results that actually matter?
Well, companies have a lot of data,
and
they just want to make sure they can do predictions on it.
Right.
The truth is they can't really today.
Mm-hmm.
The truth is today all their data is locked into data warehouses. The most valuable data is in a data warehouse today. Okay? And they've been around for 40 years. Teradata started in the 80s, and then there's been Netezza, and there's been all these old products, and there's some cloud products too, but they look like the on-prem data warehouses as well. They don't really differ. And you have all your valuable data there. You have all your customer data there. You have all your sales data there. You have all your product data in the data warehouse. That's awesome, really valuable. You can ask any questions you want from your data warehouse about the past, but you're not allowed to ask any questions about the future. Your data warehouse cannot do predictions on the future. You cannot ask your data warehouse with a BI tool, hey, tell me which of these customers are going to churn in the next 3 months. You are not allowed to ask that question. There's no data warehouse that can answer that question for you today. Okay. If you want to answer that question, you have to build a separate pipeline completely outside of the data warehouse, pull the data out, and build manual models for that, and go through sort of a lot of hassle. The future will not be like that. In the future, you'll have all your important data in one place. You'll be able to do data warehousing on it. You'll be able to do machine learning on it. You'll be able to do predictions on it. That's the most valuable thing. The things people are interested in that are less relevant, in my opinion, is how do we win StarCraft? Can we beat it? Or the next game, which has predefined rules and has a very clear reward score that we can watch and try to maximize that by lots of trial and error and simulations. That's an interesting problem that people want to solve. Or a lot of the sort of voice imaging and sort of those kind of problems, I think they exist. But for enterprises, it's more basic problems they want to solve, and it's very hard to get their data actually in a form where they can actually start doing that at scale. And once all enterprises on the planet can do that, that's going to be a big, big revolution for these companies, because these companies, each of them have thousands, if not tens of thousands of people doing it manually today. So the automation of that is going to be something that's going to happen over the next 10 years. It's going to impact the planet, mankind, those people, and those companies in massive, massive, massive ways. We're not so focused on that usually in academia.
That's a big vision. I guess that's what Databricks called unified analytics.
Yes. We're merging the merger of data warehousing and machine learning coming together and doing it for enterprises. It's going to have massive impact on the planet. So those are some research areas I would focus on that I think are going to have big impact.
Great. I look forward to that. What do you think is the most attractive thing about working at Databricks? Any final words to our students?
Yeah, I mean, we're helping data teams in any company solve some of the toughest problems in the world, right? So just to give you an example, a data scientist at one of our companies actually used Databricks to build a genomic warehouse. They actually did the alignments of the DNA on Databricks, and they built a phenotype database as well, which is all the diseases that those people had. And then they ran machine learning, rule association algorithms to find out snippets of the DNA that are responsible for the diseases. And they were actually able to create a drug for chronic liver disease that cures chronic liver disease that's in phase 1 testing using, where Databricks actually was used as a portion of this sort of much more sort of long projects to discover this drug. So those are the kind of problems that we're attacking. I think over the next 10 years, lots of these kind of problems are going to be tackled in the big enterprises. We're building basically software at the cutting edge of that. So that's interesting. Just the mission itself to help those companies solve those kind of problems is interesting. The second is we're doing this in a SaaS cloud environment. So that's also something that's an interesting challenge of doing it that way. And the company has a lot of really smart people. So I have a lot of people coming from academia saying, "Oh, this is almost like being at the university." So you get to work on really interesting problems that are actually matter for mankind. You get to do it in sort of with modern SaaS technology, and you get to work with really smart people. So I think it's awesome. I suspect Google was similar in the early 2000s. So that's why I would be interested in working here personally.
That's exciting.
Yeah.
Very encouraging. I hope students here have learned something. I have learned a lot. So do you have any final words or final questions for me?
No, I think this is really great. One thing that I would say that we didn't maybe touch on is I actually found that people that come from academia are some of the best employees, especially people that went through PhD programs. Actually make the best employees at Databricks. The most successful Databricks engineering employees went through various PhD programs. And I don't know exactly why that is, but I have a hypothesis, which is I think they're good at communication. You have to publish papers and give talks.
Yep.
And if you want to have big impact in engineering, and that's many hundreds of people, you have to convince other engineers.
Right.
So how do you communicate with other engineers? Not just through code, which is what most engineers are good at, but also through writing and giving talks. So that's one skill that they have, which makes them really sort of valuable. Two, they're really good at sort of evaluation, performance evaluation, comparing things and doing sort of being data-driven. So that also helps them because they've written evaluation sections on papers. So that's also a good thing. That's a good skill to have. The third thing I think they have is that they're resilient because PhD programs are difficult, right? You have to submit this paper, and then you get an email that says, "Sorry to inform you, but your paper has unfortunately been rejected, but you're welcome to attend the conference." A lot of those kind of rejections make you very resilient. So when you come and work on difficult problems, you're not going to give up the first time. So you keep trying again and keep trying again and keep trying again. So we've had great success with people who come from academia. So that's, I think, something that's encouraging. For me, actually, was very surprising to see that, wow, the people that really do well here, many of them have PhDs or went through a master's or something like that. They've seen this. And I was trying to figure out why that is, but my hypothesis is those three reasons. So, do your research and then join Databricks.
Cool. That's good. So I guess we'll just end the interview here. Thank you very much. It's very enlightening.
Thank you so much.
Yeah, thank you.
Take care.